So in these videos we have been talking about diagonal and trace matrices. This last couple of videos we proved these properties of trace of matrices. The trace of A plus B is equal to the trace of A plus the trace of B. The trace of KA is equal to K trace of A, and the trace of A times B is equal to the trace of B times A. I just want to call your attention before I move on to the fact that in general the trace of AB is different from the trace of A times the trace of B. Okay, you can pick any example you can try and you will find so many examples where this doesn't happen. Okay, so in general this is true. The trace of AB is not the same as the trace of A times the trace of B, so you don't see that here. Okay, so in this video we introduced the concept of identity, the identity matrix. Okay, so the usual notation is a I with an N, meaning the identity matrix for the N space. Okay, or you can simply write I for identity. Okay, so for instance, if you want the identity of 2 by 2 matrices, that will be 1 0 0 1. So this is the matrix identity for this space. Okay, the space of 2 by 2 matrices. So the identity of 3 by 3 matrices, so it's always the same. The diagonal, you get ones at the diagonal and 0 elsewhere. Okay, and you can imagine how this is for 4 by 4 matrix. 1 0 0 0 0 1 0 0 0 0 1. So you see that the diagonal, the main diagonal, is only ones and everything else is 0. Of course, this is the identity for addition. Okay, so if you pick any matrix like this is the identity 2 3 4 5. This is the identity for addition, the identity for multiplication, because the identity for what you have for addition is matrix 0. Okay, with 0 in all entries. You can check a previous video for this. Okay, so if you have a matrix A 2 3 4 5 and you want to A times identity, that will be 2 3 4 5 times, this is a 2 by 2, so that will be 1 0 0 1, right? And now you can do the multiplication and see what you get. So 2 times 1 1, 3 times 0 is 0, so you get 2. 2 times 0 is 0, 3 times 1 is 3, so you get 3. 4 times 1 is 4, 5 times 0 is 0, so you get 4. And 4 times 0 is 0, 5 times 1 is 5, and you get 5. Okay, so A times identity, you are getting A. Okay, so this is the identity for multiplication, of course. For this identity, you can use this Kronecker delta notation. It's really handy and helpful. So we write this delta ij, where you have 0 if I is different from j, and 1 for all I equal to j. So you see, if you have a 2 by 2, so in this one I is different from j, and in this one I is different from j, so you get a 0. And this is entry A11, so that's 1, right? And this is entry A2, B22, or A22, sorry, A11, A22, A22. So I is equal to j, so this is 1, 2. Well, we have been introducing the concept of trace of a matrix. So the trace of the identity, the matrix identity, since you are adding 1 plus 1 plus 1, 1 plus 1 plus 1, or if it is a 4 by 4, it will be 1 plus 1 plus 1 plus 1, where you get 4. So for I in n by n matrix, you're going to sum n ones, so this will be n.